Hello student, I will be going to discuss a very important topic, Ampere's Circuital law and related theory about it. So let's start. First of all, statement. The line integral of magnetic field in a closed loop is mu naught times the current enclosed by the loop. Look at this. This is a closed loop. Here, this is a conductor. Current passes through it is I. So current enclosed by the loop is I. So look at this. The line integral of magnetic field, that is B vector dot dl vector. Look at this, B vector dot dl vector, very small portion of the length, is equal to mu naught into current enclosed by the loop. Okay? Now we have to prove this law. Suppose consider a circular loop of radius r having center of the loop is on the axis of the conductor. So magnetic field due to this current at the point P is B equal to mu naught I by 2 pi r. Okay? The magnetic field at the point P is directed normal to the plane and inwardly. So look at this. At this point, the magnetic field vector is tangent to the circular loop, and in every point the magnetic field becomes tangent to the circular loop. So any point of the loop, B vector parallel dl vector. Okay, and B is uniform in magnitude. Now here B vector dot dl vector is equal to, look at this. This is the B dl cos 0 degree because B vector parallel to dl vector. Now look at this, B into line integral of dl. Now length of the loop is 2 pi r. So this is the mu naught I by 2 pi r into length of the loop 2 pi r. So this is the mu naught I. Therefore B vector dot dl vector is equal to mu naught I. Okay? Now limitations of Ampere's circuital law. During charging and discharging of a capacitor, a magnetic field is produced in it. This magnetic field is not obtained with the help of Ampere's circuital law. Okay? Now we have to calculate the magnetic field due to solenoid. Now first of all, definition. If an insulated wire would on a cylindrical frame and now this removes, then this form is known as solenoid. If the length of the solenoid is greater than its radius of cross section, then it is called infinitely long solenoid. Now from one end current entering the solenoid and other end current leaving from the solenoid. If the incoming current is anti-clockwise direction, the outgoing current obviously in clockwise direction. So this side becomes N pole and this side becomes S pole. Okay? Now we have to calculate the magnetic field due to solenoid. Now this is the half portion of the solenoid given in the figure. So look at this. This represents the incoming current and this represents the outgoing current. Now look at this. The magnetic field due to incoming current directed along this direction and magnetic field due to outgoing current directed along this direction. So magnetic field outside this solenoid is 0. In the same way, look at this. Here magnetic field due to incoming current this direction and outgoing current this direction. So magnetic field in this point is 0. So from this discussion we can conclude the magnetic field outside the solenoid is 0. Understood? Now look at this, the magnetic field inside the solenoid is directed along this direction, and magnetic field due to this current is also directed along this direction. So magnetic field on the axis directed this direction. Now we have to consider a rectangular loop, amperian loop. Look at this, its length is h and number of turns per unit length in the solenoid is small n. So number of turns in this portion is n into h. So total current enclosed by the loop is NHI. Understood? So now apply Ampere's circuital law. The line integral of magnetic field is equal to mu naught into current enclosed by the amperian loop. Okay? So this is the mu naught NHI. Okay? No problem? Now look at this. Look at this. This is the A, this is the B, this is the C, this is the D. Now look at this, from A to B. From A to B, B vector dot dl vector. Look at this, from B to C, from B to C, this is the B vector dot dl vector. From C to D, B vector dot dl vector. And finally D to A, B vector dot dl vector. This is the mu naught n h I. Look at this. Here B vector and dl vector are parallel. Here B vector and dl vector. Look at this. Here B vector this direction, dl this direction. So this is the 90 degree. So this becomes 0. Now outside the solenoid magnetic field is 0. So this also becomes 0. Okay. Now here also B vector and dl vector perpendicular to each other. So this also becomes 0. Okay. Now look at this. This is the B dl cos 0 degree A to B. This is the n. This is the mu naught n h I. Now here B is uniform B and dl is the h. So this is the mu naught n h I. So B equal to mu naught n I is the magnetic field inside the solenoid. Now magnetic field at one end of the solenoid becomes half mu naught Ni. Understood? Now magnetic field on the axis of a toroid. What is toroid? If two ends of a solenoid are joined to each other, then it forms a toroid. Suppose number of turns in the toroid is capital N and outer radius is B and inner radius is A. So radius of the axis of the toroid is R. Now this is the half portion of the toroid. Here current enter into the toroid. Here current enters and leaves. Current enter, leaves. Current enter, leaves. Now look at this. The magnetic field due to entering current directed along this direction and leaving current also this direction. Therefore, magnetic field. Look at this. The magnetic field is directed always tangent to the axis. So here B vector parallel dl vector. Now if we apply Ampere's circuital law, we can get the line integral of magnetic field is equal to mu naught and current enclosed by the amperian loop. This is the amperian loop. Now total number of turns is n. Current in each turn I. So current enclosed by the loop is Ni. So this is the mu naught Ni. Now here B vector and dl vector are parallel. So this is the B dl cos 0 degree. This is the line integral. So this is the mu naught Ni. Now B dl is the 2 pi smaller equal to mu naught Ni. Okay. So B equal to, look at this, mu naught this is the n by 2 pi r, this is the I. Now n by 2 pi r is the number of turn per unit length. So this becomes mu naught n I. Okay, understood? Next. Now we have to calculate the magnetic field due to thick conductor of radius capital R and current through it is I. First of all, the magnetic field outside the conductor. This is a circular loop around the conductor and center of the loop here at the axis. So here magnetic field is uniform on the loop and tangent to the path. So look at this, if B is the magnetic field, so B vector dot dl vector, and this is the line integral equal to what is the current enclosed? Look at this, this is the loop, so current enclosed is I, so this is the mu naught I. So this is the B dl cos 0 degree and this is the mu naught I. So B uniform, so dl is the 2 pi r mu naught I, so B equal to mu naught I by 2 pi r. Okay, so B equal to mu naught I by 2 r. So magnetic field B inversely proportional to R. Now if P on the, look at this, if P on the surface of the conductor, here also current enclosed by the loop is I. So magnetic field at this point, this becomes B equal to mu naught I by 2 pi r. Okay, now we have to calculate the magnetic field inside this part. Look at this, the current density J equal to I by pi r square. So current through this region of radius r is I dash equal to J into pi small r square. Now J is the I by pi r square. So this is the pi r square and this is the pi small r square. So I dash equal to I into, look at this, I into, this is the r square by capital R square. Now applying Ampere's circuital law, B vector dot dl vector, this equal to mu naught I dash. Because here current enclosed by the loop is I dash, which is I small r square by capital R square. So here B into 2 pi r, this is the I r square by r square. So B is the mu naught I by 2 pi r square. Therefore here B proportionate I. Understood? So graph between B and R becomes like this. This is the inside it. So here B proportionate R. And outside this region, B proportionate 1 by R. Okay? Understood? Hope you will understand this. Please like, share and comment on this, and don't forget to subscribe my channel to get this type of conceptual video which will be very beneficial for you.